Hi everyone, welcome back to DMG chemistry classes, and today I am going to discuss enthalpy of neutralization. And in this video I am going to explain very important and interesting aspects of heat of or enthalpy of neutralization. So keep watching this video till very end and also subscribe my channel. So friends, when we mix 1 gram equivalent of an acid with 1 gram equivalent of a base and vice versa, that is 1 gram equivalent of a base with 1 gram equivalent of an acid, and if they react completely, then the resulting solution is neither acidic nor basic. That solution is neutral, and this reaction is called as neutralization reaction. And the heat evolved in this reaction is called as enthalpy of neutralization. And in these reactions, heat is always evolved. So let us define enthalpy of neutralization. So the enthalpy of neutralization is defined as the enthalpy change, usually the heat evolved, accompanying the complete neutralization of 1 gram equivalent of an acid with 1 gram equivalent of a base or vice versa in dilute aqueous solutions. And I will explain in this video that what do we mean by 1 gram equivalent of an acid and 1 gram equivalent of a base. And further, I will also explain that why we have taken 1 gram equivalent of an acid and 1 gram equivalent of a base. It could have been 1 mole of an acid or 1 mole of a base, but we didn't take. Okay, so I will explain, so keep watching this video. And further, why we have taken this dilute aqueous solutions? Because when the solutions are dilute, that is solute is in lesser quantity and the solvent is in larger amount, then there will be complete dissociation or the complete ionization of acid and bases. So that's why we have taken here dilute aqueous solutions. And further, a very common example of acid base neutralization reaction is reaction between 1 gram equivalent of NaOH and 1 gram equivalent of HCl, giving us NaCl, that is salt and water. And heat liberated during this reaction, delta H is equal to minus 57.1 kilojoule per mole. And sometime I ask my students that what do you mean by a salt? And then they are unable to explain. So then I used to tell them that the salts are the products of acid and base neutralization reaction. When acid and base react with one another, they neutralize each other and the salts are formed. And salts are composed of two radicals. One radical is called as acidic radical. Here, negatively charged radical, that is Cl negative, it comes from acid, that is it comes from HCl. So this radical will be called as acidic radical, whereas the positively charged radical, that is Na positive, it is coming from the base, so it is called as what? Basic radical. Understood? And I used to ask this question during the salt analysis or the inorganic mixture analysis. Further, in the definition, I said that 1 gram equivalent of an acid is neutralized by the 1 gram equivalent of a base. But if we see the units of enthalpy of neutralization, then the units are kilojoule per mole. Okay, so I will also explain this, that why the units are not kilojoule per gram equivalent. Okay, and units are kilojoule per mole. So keep watching. And it is very interesting concept here that the enthalpy of neutralization of any strong acid, that is HCl, nitric acid, sulfuric acid, with a strong base like lithium hydroxide, sodium hydroxide and potassium hydroxide or vice versa, is always same, that is 57.1 kilojoule per mole. A very interesting concept. That is, if we take any of the acid or any of the base from here, then same amount of heat will be liberated. And this is explained on the basis of complete ionization of strong acid, strong base and their salt in the dilute aqueous solution. Okay, what I am trying to say, that strong acid, strong bases and their salts are completely ionized in the dilute aqueous solutions. So let us explain it. So as I said that the strong acid and bases are completely ionized, so the NaOH can be written in this manner, that's Na positive plus OH negative, and further HCl can be written like this, that is H positive plus Cl negative, giving us Na positive plus Cl negative, because NaCl is strong electrolyte and is also completely ionized, plus unionized water. Understood? And the overall reaction will be that this Na positive and Na positive will be cancelled, and Cl negative and Cl negative will also be cancelled. So we will be left with what? H positive plus OH negative, and H positive and OH negative giving us water. Okay, so this is the overall neutralization reaction. And here, as I said, the enthalpy of neutralization is minus 57.1 kilojoule per mole. Understood? Now let us take a different acid and base. So here I have taken potassium hydroxide base, and it is again completely ionized, being a strong base. So I have written it K positive plus OH negative. Likewise, here I have taken nitric acid, and it is written H positive plus nitrate ion, and giving us potassium nitrate, okay, K positive plus NO3 negative, and water. And here also the overall reaction will be K positive cancelled, and nitrate ions and nitrate ion. So here also we are left with H positive ion and OH negative ion, and the right hand side we are having water. So overall neutralization reaction in this case is again same, that is 1 mole of H positive ion is combining with what? 1 mole of OH negative ion, giving us 1 mole of water. Okay, so that's why the units of heat of neutralization are expressed. This heat of neutralization is expressed in terms of kilojoule per mole, because in this case 1 mole of H positive ion is reacting with 1 mole of OH ion, giving us 1 mole of water. Understood? So this is how we can explain that why strong acid and strong bases, they have same enthalpy of neutralization, because in both the cases the overall reaction or the overall neutralization reaction is same. Okay, but if we have a weak acid and a strong base, or a weak base or strong acid, or both acid and bases are weak, then the heat evolved during the neutralization process will be less than 57.1 kilojoule per mole. Let us explain it. So here I am taking a weak acid, acetic acid, and strong acid, sodium hydroxide. And as we all know that these weak acids does not ionize completely, and acetic acid, its ionization will be represented in this manner, that is it plus H positive. Okay, so it is a weak acid, and weak acids are not completely ionized even in the dilute aqueous solutions. So its ionization will be an equilibrium reaction. Okay, and if we want to ionize it completely, then we have to supply some heat or some energy from outside, and to completely ionize acetic acid, the heat required will be equal to plus 1.9 kilojoule per mole. Understood? And NaOH is a strong base, it is completely ionized, doesn't require any type of heat for its ionization, it is completely ionized. Okay, and when the neutralization will take place, what will happen? The H positive ion given by your acetic acid, they will react with the OH ion given by the base, and the neutralization reaction will be H positive ion, that is 1 mole of H positive ion will combine with 1 mole of OH negative ion, and giving us unionized water. In this case, the heat will be liberated, or heat will be given out, and the amount of heat will be minus 57.1 kilojoule per mole. Okay, as I have explained earlier, that when 1 mole of H positive ion react with 1 mole of OH negative ion and giving us 1 mole of water, this much amount of heat is released. But here we are not going to get this much amount of heat. Why? Because here we have already invested or given some heat for the ionization of acetic acid. Then what will be the net heat released? So net heat released, in this case, net heat released will be equal to minus 57.1 plus 1.9, and it will be equal to minus 55.2 kilojoule per mole. Okay, so in this case the heat released will be less than minus 57.1 kilojoule per mole. Understood? And we can also explain this concept in another way. Let us consider that in this container, okay, I will mix 1 gram equivalent of acetic acid and 1 gram equivalent of your sodium hydroxide. Okay, then the sum part of the heat released during this reaction, some part of the heat released during this reaction will be used to ionize the unionized acetic acid. What does it mean? It means that during this reaction heat liberated will be minus 57.1, but out of some part of this heat, that is equal to 1.9 kilojoule, will be used to ionize the acetic acid. Then the net heat released will be equal to minus 55.2 kilojoule per mole. Okay, so part of heat released is used to ionize the unionized acetic acid. Okay, so this is why in this case the heat released is less. And further, if we have weak base, that is we have weak base like ammonium hydroxide and a strong acid like HCl, in this case also the some amount of heat released will be used to ionize the weak base, and in this case the heat required to ionize ammonium hydroxide is equal to 5.6 kilojoule per mole. Then what will be the amount of heat we get? So the heat released or the enthalpy of neutralization will be equal to 57.1 minus 5.6, and it will be equal to 51.5 kilojoule per mole. Okay, so in this case also the amount of heat released or the enthalpy of neutralization will be less than minus 57.1 kilojoule per mole. Understood? And now I am going to discuss a very interesting and very important concept which I mentioned in the beginning of this video, that why we use 1 gram equivalent of an acid and 1 gram equivalent of a base instead of having 1 mole of an acid and 1 mole of a base. Okay, so friends, I told you that the overall neutralization reaction involve the combination of 1 mole of H positive ion with 1 mole of OH negative ion, giving us what? 1 mole of water. So 1 gram equivalent of an acid always gives 1 mole of H positive ion, whereas 1 mole of an acid may or may not give 1 mole of H positive ion. And similarly, 1 gram equivalent of a base, it will give us 1 mole of OH negative ions, whereas 1 mole of a base may or may not give us 1 mole of OH negative ion. So let us explain it. It's very interesting. So we will first of all discuss that what is 1 gram equivalent or 1 gram equivalent of an acid. So let us take example of sulfuric acid, okay, H2SO4, and I have taken 1 mole of sulfuric acid, okay, and 1 mole of sulfuric acid, when 1 mole of sulfuric acid ionizes, then it ionizes in this manner, giving us 2H positive, giving us 2H positive plus sulfate ions. Okay, this means that 1 mole of sulfuric acid is giving us 2 moles of H positive ion. Okay, and we also know that this 1 mole of sulfuric acid, it will be equal to its molecular mass, and its molecular mass is 98 grams. Okay, so this 98 grams is giving us 2 moles of H positive ions. Okay, now let us discuss what is 1 gram equivalent. Okay, so 1 mole is equal to molecular mass. Now I am going to discuss what is 1 gram equivalent. So 1 gram equivalent of this sulfuric acid, it will be equal to its equivalent mass. And what will be its equivalent mass? Equivalent mass will be its molecular mass divided by its basicity. Its equivalent mass will be equal to its molecular mass divided by its basicity. And what is basicity? Basicity is the number of H positive ion donated by the acid. So here, how many H positive ion we are giving? 2. It is giving 2. So its 1 gram equivalent will be equal to 98 divided by 2, and it will be equal to 49 grams. Okay, understood. So now we can say that it's 1 mole, okay, 1 mole, which is equal to its molecular mass 98 gram. So 98 gram, which is also what, 1 mole, is giving us how many moles of H positive ions? 2 moles of H positive ion. Okay, then 1 gram equivalent, which is equal to how much? 49 grams. Okay, then it will give how many moles of H positive ion? It will give us 1 mole of H positive ion. You can see, divide this equation by 2. After dividing it by 2, we will have what? 49, and here we will have 1. It is easy. It can be easily understood that if 98 gram is giving us 2 H positive or 2 moles of H positive ion, then 49 gram will give us 1 mole of H positive ion. And what is 49 gram? It is 1 gram equivalent. So the 1 gram equivalent of an acid always give us 1 mole of H positive ion. Let us explain with another example. So here I am having this phosphoric acid, and this phosphoric acid is giving us 3 moles of H positive ions and a phosphate ion. Okay, and as I said, here we have taken its 1 mole. Okay, then its 1 mole will be equal to its molecular mass. Okay, and its molecular mass is giving us 3 moles of H positive ion. Okay, now I will divide both sides by 3. So I will have what? Molecular mass divided by 3 will be equal to 1 mole of H positive ion, because I have divided both sides by 3. And what is this 1 molecular mass divided by 3? This is molecular mass divided by what? Basicity of phosphoric acid, and it will be equal to its equivalent mass. As I said, it will be equal to its equivalent mass, and its equivalent mass is what? 1 gram equivalent. Okay, 1 gram equivalent. Understood. So in this way, 1 gram equivalent of this orthophosphoric acid will give us what? 1 mole of H positive ion. So keep in mind, forever that 1 gram equivalent of an acid will always give us 1 mole of H positive ion. And the acids like your HCl or nitric acid, they are monobasic. Their molecular mass and their equivalent mass will be same because they are monobasic. Their basicity is equal to 1. So they will always give us 1 mole of H positive ion. Okay. So now let us discuss that how 1 gram equivalent of a base give us what? 1 mole of OH negative ion. Okay. So I have taken example of calcium hydroxide. Okay, and this calcium hydroxide ionizes in this fashion, giving us calcium ions plus 2 OH ion. Okay, and here 1 mole of calcium hydroxide is giving us 2 moles of OH negative. Okay, and here 1 gram equivalent of calcium hydroxide will be equal to its equivalent mass. And equivalent mass of a base is equal to its molecular mass divided by its acidity. Okay, and what is acidity? Acidity is the number of OH ions donated by the base. So here the base is acidity of calcium hydroxide is 2 because it is giving us how many OH ions? It is giving us 2 OH ions. So this 1 gram equivalent will be equal to its molecular mass divided by 2. Okay, beta. So now it's 1 mole. It's 1 mole which is equal to its molecular mass. 1 mole equal to its molecular mass, and it is giving us how many? 2 moles of OH negative. Okay. Now I will divide both sides by 2. Then what I will have? I will have this molecular mass divided by 2 equal to 1 mole of OH negative after dividing both sides by 2. And what is this molecular mass divided by 2? It is the equivalent mass of calcium hydroxide, and the equivalent mass is equal to what? 1 gram equivalent. 1 gram equivalent of what? Calcium hydroxide. Okay, so the 1 gram equivalent of calcium hydroxide, which is equal to equivalent mass, will give us what? 1 mole of OH negative ion. Understood? So in this way we have explained that 1 gram equivalent of a base will always give us 1 mole of OH negative ion. Understood? And further, if I take 1 mole of NaOH, okay, then after dissociation it will give us 1 mole of OH ion because its equivalent mass and molecular mass will be same because it is monoacidic. And if I take 1 mole of this sulfuric acid, then after dissociation it will give us sulfate ion plus 2 moles, that is 2 moles of H positive ion. Okay, and if I mix 1 mole of NaOH with 1 mole of H2SO4, neutralization reaction is not going to complete. Why? Because 1 mole of NaOH is giving us 1 mole of OH negative ion, whereas 1 mole of sulfuric acid is giving us 2 moles of OH ion. So 1 mole of H positive ion will react with 1 mole of what? OH negative ion given. Whereas here 1 mole of H positive ion will remain unreacted. Understood? So the neutralization reaction will not be complete. What if I take 1 gram equivalent of an acid and 1 gram equivalent of sulfuric acid, then it will give us 1 mole of H positive ions. And if I take 1 gram equivalent of NaOH, and it will give us what? 1 mole of OH ions, as I explained earlier. Okay, then the neutralization reaction will be complete because we are getting 1 mole of H positive ion and 1 mole of OH negative ions. Understood? So friends, these were the various aspects of this heat of neutralization or the enthalpy of neutralization. Okay, so keep watching my videos, and also like and share my videos and subscribe my channel. Thank you very much.